let's talk about sample size calculations. So suppose we wanted to estimate P, that is the proportion of all Americans who use a smartphone today. How many people would we need to randomly sample to guarantee that the resulting 95% confidence for P has a width of at most 0.01? Well, we have that the general formula for our interval is P hat, this is the critical value times P hat times 1 minus P hat over n, right? And we want to calculate this n. So we are given that if we have P here, sorry, this should be a P hat here, and remember that we define the confidence interval to be the point estimate plus or minus our margin of error. So the margin of error in this case should say that our confidence interval is going to be P hat, and this quantity here is the margin of error, and here we have the same. It's going to be plus a margin of error and minus a margin of error. The margin of error in this case is going to be this quantity here. And if we want the interval to has a width of at most 0.01, we want this quantity, this width of the interval, to be less or equal than 0.01. So that means we want 2 times the margin of error to be less or equal than 0.01. And the margin of error in this case is 1.96 because this this critical value for 95% confidence. We approximated with 2, but now that we know how to calculate it, is 1.96 exactly. And we have here P hat times 1 minus P hat over n. And we know that this P hat times 1 minus P hat is something that we already discussed. The maximum value for this, having in mind that this P hat is between 0 and 1, the mass of P hat times 1 minus P hat is 1 over 4. So this quantity is less or equal to 2 times 1.96, and this is the square root of 1 over 4 times n. And we want this to be less or equal than 0.01. That is our condition here. So we need this quantity to be less or equal than 0.1. So if we solve this in equation for n, we will find that n should be greater or equal than 38,000 people and 416.